Hello and welcome to the October instalment of the Data Center Construction Channel. I'm Emma Brookes, I'm Head of Channels at DCD, and I'm delighted to introduce this episode on building high-density data centers sustainably in India. And thank you, of course, to CtrlS Datacenters for partnering with us on this episode. So with me here today, I'm delighted to be joined by Brahma Reddy Kasu, who is the President of Data Center Infrastructure at CtrlS. Mukesh Kumar, who is the Technical Director at AECOM, and Amol Dandgaonkar, who is the Data Center Discipline Head for Mission Critical Infrastructure at Arup. So thank you very much for joining me today, gentlemen. How are you?
Yeah,
Good. Thank you.
Great. No, thanks so much for joining me. So I suppose to sort of set the scene a little bit, I'd like to talk around how the high density data center market is developing in India. So Brahma, if I can maybe come to you for this one first, how do you see the high density market in India developing, and how much demand are you seeing now, compared to say 1 or 2 years ago?
It's good. It is very well across the industry nowadays, in terms of the data center boom, the way things are happening. So if you look at the 2 years ago, the data center market in India, of course, we should look at Indian data center market before COVID pandemic and after COVID pandemic. The complete dynamics are changed, right? So if you look at in 2020, 2022 to that extent, our capacities were anywhere between zero point 0.5 to zero point 0.6 gigawatt across the country capacity. What is today is around 1 to 1.2 gigawatt of the capacity. It is almost double the capacity compared to the last 2 years in the India. So even to that extent, the revenue, if you look at now, India is anywhere between from last 2 years. 2 years ago, it was around some 3.54 billion USD. Now it is around 9 to 12 USD. So it's rapid growth, rapid growth. That is primarily driven by the cloud hyperscalers in India precisely, and the some extent HPC, high power computing, some extent. These are the primary drivers so far. But what we see from now is exponential growth, the kind of demands that are coming from our hyperscale customers, and the neo cloud is one thing is seriously driving for AI and GPU workloads. So the neo cloud, the players or the users are inquiring with us, not only with us, all the data center players in India, that do you have a large format campus capacity ranging from 500 megawatt to 1 gigawatt, or do you have potential to go beyond 1 gigawatt? Those kind of requirements. Why? Because these are all coming from AI workloads primarily, and HPC computing, and these are primarily driving this. Of course, the traditional hyperscale cloud networks anyway is already in place. These are the key driving factors to have Indian data center market going forward. What we see now, and the support, the new capacity that are coming up in the market. Okay, there are certain key factors in India that is actually supporting and looking at lucrative for the neo cloud players in the globe or the hyperscale or HPC users, is that the all developed states in India is having almost surplus power. The power is one of the key blocker, and sufficient the required resources around making them, and multiple players in India including CtrlS, is planning to have multi-city, multi-gigawatt campuses. For example, if you look at CtrlS, is looking at least 4 large format the hyperscale data centers or neo cloud kind of compatible data centers, anywhere ranging from 500 megawatt to 1.2 gigawatt. All plants are in place everywhere, almost our plants started. So this is a kind of the demand in India which is coming up, and we see the phenomenal growth, present and going forward.
So thank you very much, Brahma. So, Amol, from your perspective as well, how are you seeing kind of the high density market developing in India, and what are the sustainability challenges alongside that?
So Brahma is rightly picked up about the growth, what is happening in India from last 2020 till today. But I'll just add a few points to it that India's high density market is on fast track evaluation, and it is mainly driven by the digital transformation, adoption of AI, surge in consumption. So I'll say it's not only growing up, it's literally transforming. Okay. And high density infrastructure is no longer niche for, in India. It's becoming a new standard, and India is just catching it up. It's carving out leadership role in delivering cost-effective, scalable, and AI-compatible infrastructure. So I can say on explosive growth trajectory, the capacity in early in 2019 or 2020, it was half a gigawatt, close to that. But right now, it's been reaching towards 1.5 gigawatt of capacity and expected to reach by 7 gigawatt by 2030. Again, these are a few numbers from the reports from available on the market, and you can talk about the rack densities that has been gone from the 5 kilowatt till 30, 40 kilowatts per rack, and even trying to go even more on that. Apart from that, the high density marketing on cooling innovation, it's really doing a base research are happening at the background, developments are happening, and implementing of advanced cooling solutions like of immersion cooling, liquid cooling, rear door heat exchangers are being evaluated on day-to-day basis. In addition to that, power infrastructure, if I talk, again, it is enhancing on day-to-day basis to support the redundancy and the sustainability challenge. Most of the developers, hyperscale clients are showing interest towards going for the green energy to just adopt the incentives provided by the government of India. Then support from the authorities are happening at the moment, and the lands are obvious, at low development cost. So this is, I can see, most of the things, the high density market developing in India. But when it comes to the sustainability challenges, I know we keep on talking on sustainability a lot more, but because of high density markets, it's a real challenge for all of us. We have to just look after our environment impact as well, and there are few challenges like energy consumption. So because of AI driven thing and high density racks, there's a huge and significant demand for data centers. I'll say more power is adopted on per square foot basis, and due to this, it leaves a huge carbon emission in the environment, and we can reduce it by obvious using some by using renewable resources. Cooling requirements are there, so due to dense configuration, a lot of heat is getting generated. Okay, so team has to work out a different cooling options. Right now, everyone is opting for the air cooled solutions. Okay, it's a trend in the market, but we need to think upon how we can utilize the wastewater or maybe a kind of water based chillers, and that is, I can see a practice is adopting day by day in Indian market. The most important is about e-waste and the material life cycle. Due to rapid hardware growth, there's a significant electronic waste is happening in the market, and this really leaves a heavy impact on the environmental pollution and resource depletion. And to mitigate these circular economic practices, reuse, recycle, and responsible disposal of this material is at of most important. Then I can say measuring of carbon footprint is also a real challenge. Right now, there are no secure tools available in the market, but slowly, developments are happening. I'll say again, stress on the infrastructure is one of the things through which we are just losing a lot of losses on the power grid. Then construction materials, so things are developing, and more and more materials are getting research who those materials are supporting the sustainability challenges of I can say the of India or the globe. Yeah.
That's great. Thank you so much, Amol. And actually, you've teed me up quite nicely to go into our second talking point, which is on adapting to and designing for liquid cooling. And you mentioned there the sort of the transition from air to liquid. So yeah, Mukesh, if I can turn it to you, kind of what are you seeing at the moment in terms of kind of design choices for cooling, and how can facilities be engineered today to kind of, I guess, to allow that future flexibility for new cooling methods? Are you seeing perhaps designs to accommodate liquid cooling in the future potentially?
Yeah, so okay. Hello everyone once again. Okay, thanks Emma for providing the opportunity, okay, to discussing these technical and sustainable solutions here. So nowadays, if you talk about data centers, generally Brahma and Amol covers very good points, okay, and about data center and how the market grows and shifting towards the new development and increasing the capacities nowadays from the client side. So what we as a consultant, saw the market when we are working with multiple hyperscaler, the international clients and local clients. There is a real shift now in from last 5 years. Okay, if I talk about when I entered in a data center, so it's 80 megawatt, 90 megawatt we are talking about on a data center. Now we are talking about 800 megawatt or 1000 gigawatt right now in India. Okay, which is going to be bigger number as already explained by Amol also. So clients are very proactive and aggressively taking actions like how to increase the capacities. Definitely, there is a major role is the AI and the high density racks. Again, the second challenge in India, the selection of the land and power availability when you are doing, the data center planning in any of the state. Then there are a lot of, government regulations and approvals, which client need to be in mind while selecting the, land, space, water availability, and then, again the building height, because it's totally depends upon first of all the land. If you have the land, yes, definitely the single story or dual story can work. Uh, but most of the clients, if we see where we have the challenges, it's the multi-story. Multi-story means when we are talking about it's a G plus 6, G plus 7. Okay, then the mechanical floors also need okay then another two floors for the mechanicals, because when you talk about the systems, it's a huge system other than IT also. When we talk about data center, people talk about IT. Okay, but with IT, you can imagine the how big the electrical system for this data center is coming in. Okay, the number of DGs on each floor, electrical rooms, electrical panels, switch gears, GIS, taking the power from the government authorities. It's a big challenge. Lot of approvals are in between where the clients and along with the consultants, which need the another level of expertise, okay, for here. And definitely when we talk about the new cooling systems, and right now even uh, clients start thinking about the CLC and WCC coolings, but most of the clients are still with the the ACC, because this both type of cooling comes with their own pros and cons, and then the space requirement. Okay, I am even my team is working with the multiple data centers, where because of the different type of cooling arrangement we need to eat up the IT capacity, because definitely once the equipment came in, let's take an example of WCC chillers, then the cooling tower, then the pumps, they came in, they need their own space in the building. So because of that, the another challenges came in, and every client have the commitment of this much megawatt we need to launch on this particular date. So that's challenges definitely we are mitigating, discussing with client, and the evaluation of new technologies. Really, I can say will take this business to the new heights in coming years. Yeah.
That's great. Thanks so much. And Brahma from as well. Um, Mukesh there touched on that kind of flexibility element. So how can operators maintain that flexibility and future proofing when cooling requirements and GPUs can change so rapidly?
Yeah, nice question for data center operators. This is one of the big challenge. I split this overall problem into two. How to solve this problem in terms of scaling the capacity in the existing data centers, which are operating from last 15, 20 years in the market. And of course, whatever that was evolved last 5, 6 years to double the capacities, and how to accommodate the new densities and the new AI workloads into the existing data centers is one of the biggest challenge for operators like us, CtrlS. And the other point is how do we support going forward for our customers? Not only now, today, 5 years back, what we thought through is today is not the same as you're writing how we can make it future proof. What we are doing today may not be relevant after 5 years or 6 years or 10 years down the line. So somehow at CtrlS we envisaged this, not now, even 10 years ago, 15 years ago. If you look at our Mumbai data center, we designed that point in time, average power densities are anywhere between 3 to 5 kilowatt per rack. So that point in time, we envisage the densities may go up to 30, 40 kilowatt, not to the extent of today's demand of 100, 200, 300 kilowatt per rack, but we envisage to the extent of 25 to 30 or 40 kilowatt per rack. So accordingly, we sized our infrastructure at CtrlS, if you look at. So where our existing customers who are from the banking background, enterprise customers, cloud customers, they deployed their workloads anywhere from 5 kilowatt to 15, 20 kilowatt so far. Now the same customer wanted to, scale up or upgrade their infrastructure, which was supporting traditional computing to their, GPU computing or AI workloads. So as a operator, we have to accommodate. They cannot go and source elsewhere because their whole ecosystem, network ecosystem, everything built there. So for that, somehow our data centers are supporting and we could able to revamp. So how it is possible? Bringing flexibility and scalability and modularity into our designs while designing and constructing. That's where today we could able to sustain in the market and serve our existing customers. Next, coming to the present upcoming demands, what are the key factors that we are factoring while having our experience in terms of scaling the customer requirements from traditional computing to GPU or AI workloads. There are a couple of key things that we need to keep it in mind. As Mukesh rightly mentioned, the customers are very flexible. At the same time, they are very demanding. Even the customer user base is not clear what exactly they want as on tomorrow, because the industry markets are so dynamic, where the requirements are changing every day almost. So a few customers started talking to us 30 kilowatt per rack average, and the same customers after 1 month they are talking about 75 kilowatt per rack, and same customer now is talking about 150 kilowatt per rack. So this is a huge change. Even the engineering teams out of the customer base is not fully certain with their end users requirement. So keeping all this version, so at CtrlS and all the data center market and the consulting engineering firms like Arup or AECOM, they're all working towards how to bring a lot of flexibility in overall infrastructure. And there are key factors in the infrastructure to be looked at and to serve future after 5 years or 10 years workloads to take up. One is most important thing now, the neo cloud players and hyperscale players are looking at how can they scale from 10 megawatt data center to 1 gigawatt data center. For that, what is required importantly is the large format data center campuses. Large format. They are now the customers are looking at, earlier we used to say 10 racks, 15 racks, went up to 1 megawatt to 10 megawatt, 100 megawatt. Now people are talking about 1 building to 10 buildings. So for that, what customers are looking at is large scale formats, campus, where they can expand from, let us say, 10 megawatt to 1 gigawatt capacity. That makes a lot of sense for the neo cloud players or the hyperscale players, because the most of the AI workloads are large language models or a lot of HPC computing. For that, they are looking at low latency network infrastructure, which is possible within the given pod. Right? So that is possible when we enable large scale formats in terms of the campus of 1 gigawatt in size. That is one. Second one is we need to have our site selection criteria absolutely intact, which can have feature load, taking care of feature loads. Means, power grid. Power grid is another key aspect, is that your power grid and power supply is available to cater feature 1 gigawatt in the specified data center campus. That is the second one. The third one, what we need to look at is, while constructing a building, is that building is going to shall be sufficient for today's workload of, let us say, 100 kilowatt per rack to tomorrow 1 megawatt of per rack capacity. For that, what is required structurally? Two elements: sufficient horizontal space, floor loading capacities, and floor to floor height. So that means the structure is capable of taking feature loads. So we need to look at our structure is quite flexible. Same way in the power. Power also, we have to have our complete lineup. Our power module should be sized in a manner. The same power module can support 5 kilowatt to 100 kilowatt to 1 megawatt of power supply to each rack. So that means your power module sizing, our power module location, and distribution networks should be sized to, cater future capacities of power. Same way, cooling. Cooling is the very, very tricky situation. Power, space can be accounted, but the cooling has its own physical limitations. So cooling. So that's where we are building for all existing data centers and upcoming data centers with a lot of flexibility in the cooling designs. Let us say same data center can support 100% of customer requirement in air-cooled GPUs. At the same time, the customer is opting for 50% air-cooled GPUs, 50% liquid, or 90% GPU workloads. That means liquid cooling loads, and another 40% the air cool. That kind of flexibility we are building in our vertical piping network, horizontal piping network, and terrace piping network all across. So this is another very, very important. Most of the data centers nowadays struggling for provisioning of cooling rather even power can be drawn from any corner of the campus or the building, but the cooling should be in the defined locations, right? So similar way, our automation, infrastructure, scalability, all that we need to size, look at future after 5 years, what is going to happen. That we looked at 10 years back. That's where we built India's first largest capacity tier 4 data center in Mumbai that is still serving even hyperscale customers and the AI customers. They simply seamlessly replaced their traditional computers with the GPUs. So that's where, so at operators, to address this particular point, it's definite challenge, but we need to ready with these kind of flexibilities. We need to bring those flexibility in the core infrastructure. Power, large format campuses, our power should be so much flexible to cater whatever kind of loads, your cooling provisions. Those are the key elements to look at flexibility and support future customers.
Thank you very much, Brahma. And speaking of that scalability, I'd like to take a bit of time to dive a bit deeper into the power scalability that you touched on, and how I suppose renewable energy is being used to support the high density transition in India, and kind of what are we seeing in terms of the different energy mixes on the grid. So Amol, if I can maybe go to you for this one first, how is the development of renewable energy in India further supporting the development of data centers at the kind of the scale of build out that we're seeing at the moment?
Just to give a hints on that, India's renewable energy market is absolutely surging like anything. And I would say this year is a really good year for the renewable energy sector. They have really done a well. And I'll say India is at the moment third largest renewable energy producer in globally. And really, the solar power dominate the other resources. As on that, if I talk in numbers, so far we have 442 gigawatt of renewable energy plant. Out of that, probably 210 gigawatt is installed capacity, 160 with solar and 50 of wind, and it is expanding and plan to expand to 4x of its capacity. So by 2030, the country is targeting to reach, you can say, 500 gigawatt of non-fossil fuel, positioning themselves as a global clean energy powerhouse provider. And in terms of investment, so investments are at the moment are close to the 29 billion US dollars. So this is the overall growth right now India is seeing as a part of renewable energy, and really coming years are really challenging and would be really tough for each of us to help in growing the renewable energy sector equally, because we as a data center developer are acquiring a lot of power, correct? And obviously when we talk about the environment, we are leaving a huge impact on it. So we need to make some way for the renewable energy as well, and we have to support as much as we can.
Yeah, absolutely. Yeah. And as well as that kind of development, how, for example, Brahma, how is this being supported with on-site generation in the form of, solar energy, for example? Do you think we'll see this more going forwards, given the scale of demand that we're seeing in India at the moment?
It is actually, it's a very good thought. of having energy, the data center right next to the energy park, or bringing energy generation to the data center park. It is very interesting, very effective solution, but India is slightly behind on this thought process at this moment. If you look at the Middle East precisely, okay, they're already very advanced stage where the most of the data centers are going right next to the solar park, solar farms. Okay, the concept called as behind the meter concept. Okay, in India we explored significantly in terms of bringing this value proposition. So, which will there are two advantages by bringing the behind the meter concept. Okay, means in data center going right next to the solar park or any renewable energy source, or otherwise bringing that close to the data center. One is we are avoiding all kind of losses and avoiding the burden on the transmission and utility network. Time is the cost of, see, in India, let us say the energy cost is $0.50 actual generation. By the moment it reach to the data center, it becomes almost a $1 per unit. That is the situation, right? So to avoid all these transmission losses, wheeling charges, and reduce the burden on the utility network and utility, the grid, and also bringing a lot of efficiencies. This is the great thought, but India is slightly behind. There are various. Technically, is that doable in India? Yes, very much doable, because the right next to the any highway across the country has plenty of land, and solar parks also seen very much, and the networks are the to reach or to establish a data center right next to a solar farm across the country. The major challenge is road connectivity. Second one is the network accessibility and willingness to go there. These are the three. So currently, network infrastructure is very much established along with the highways from the city to city or state to state. And the solar parks are available right next to highways. And what is now missing factor is the willingness, including resource mobilization, going there and all. Those are the challenges. But very near future, I see a great potential in India that people going for the data center right next to solar parks, like a behind the meter concept. But to give you one perspective here, the like Dubai I'm talking about. Okay, in Dubai and Australia, certain data centers almost are going close to the solar parks, and at CtrlS we always innovate, try to explore opportunities like this. I give you one example in 2017, 2018, that in Mumbai we built one of the country's tallest data center with, let us say, approximately 76, 80 meters. The whole building was initially proposed with the facade elements with the glass or some kind of dead walls, and we thought of leveraging solar modules pasting on top of the elevation. That's where we covered a complete building with the solar envelope. So we could able to generate since 2017 almost a 1.2 megawatt of renewable energy out of the building. That is helping in compensating somewhere here and there. Similar way we did in Chennai, almost a 1.8 megawatt we are generating out of our building elevation. Okay, so these are the few examples to look at our efforts towards bringing power closer to the data center to avoid the wheeling losses or transmission losses or the additional cost or reduce burden on the grid. But large the future, I think I see a great opportunity where people going closer to renewable energy and behind the meter.
Yeah, fantastic. Thank you, Brahma. And of course, there are other technologies developing alongside this as well. So, Mukesh, if I can turn it to you, for example, how is the development?
And I just wanted to add one more. Point here in Maharashtra, state of Maharashtra, at near to our Mumbai data center. We are the first people to establish 156 megawatt captive solar park, which is generating energy, let us say 300, 400 kilometers away from our data center. And we are wheeling that power and connecting to our data center. So almost 60 to 70% of our energy in the Mumbai campus is fed from renewable energy. So we are in an advanced stage. We are looking for, the customer who is willing to come along with us far away from the metro cities, where they'll definitely get a lot of benefit out of it.
Thank you very much, Brahma. And of course, alongside the development of renewables, we also have the development of technology to support that. So, yeah, Mukesh, if I can turn it to you, how, for example, how is the development of technologies such as battery energy storage systems supporting that transition to more sustainable sources of power, as Brahma's touched on?
Okay, yeah. First of all, very happy to hear from Brahma related to this Mumbai data center and the solar. Yeah, really, because while working with the many of the clients, they are really struggling of doing this solar and how to keep this sustainable things from electrical point of view in. Because generally, when we are making the data center and especially if ACC cooling and other cooling, complete data center roof is used generally to place the chillers. So the technology, yes, we want to implement, but we are sometimes not able to find the space to put up the solar panels. Okay, so this is rightly mentioned by Brahma, like using the solar somewhere, okay, else, and then bringing the power to the data center. It's fantastic here. So in the same way, like we have the nowadays, I'm working with the client for the BAS, and to finding out the solutions of how to use these type of systems in the data centers. We worked out basically for this particular system with the international clients, and right now this BAS is not too much implemented in India. But when I talk about, we are doing the data centers in the Holland. Okay, we are doing in the Helsinki. So there, the clients are interested to implement this. Okay, the good thing is, one is the technology. Second thing is, the space. BAS required their own space. When you are putting up, the 5 megawatt or 10 megawatt, each 40 feet container. Okay, for even the half of the capacity of the data center, then it's need a huge space and underground cabling system to connecting to the data center. But yes, now in India, the some of the states having reliable grid system, but still some of the state don't have. Okay, so now clients, it's same like CLC, WCC or ACC type cooling. Same like now the clients are thinking about, like, what is the how can we use the battery energy storage system in our data center. I am right now working with the Indian clients also, and we are working with the OEMs, because if we talk about the wholesale India, this system is not too much available with the OEMs. Some of the OEMs recently I came across from the 6 months, they came up with the technologies that also they are bringing the technology from the international offices, like 2 megawatt, 5 megawatt maximum container size up to now I find is a 5 megawatt. So you talk about 5 megawatt one container, and if you are catering the half of the capacity of 100 megawatt, 50 megawatt, you come with lot of containers. You cannot stack the container because of the regulations. You need to place on a ground, and foundation came in lot of things. Okay, right now, yes, working with many clients to working how to mitigate these challenges to implement the technologies and making the data center green. Definitely, when BAS came in, definitely we can reduce the DGs. So when we are reducing the DGs, definitely the diesel aspect is reducing. Your high-speed diesel storage system is reducing for that much capacity. So yes, solutions are available, but according to country and the local norms, we need to think about like how to implement. Related to same the like gas based or hybrid backup solutions, we came across with many clients. Even on one place we implemented, okay, diesel is running on a biofuel, diesel plus gas. Okay, when the gas is available, it run on a gas. But then finding a gas on a locations where we are clients are coming up with the data center, it's a challenge. Somewhere the pipelines are not available. So even as a consultant, we are also in discussion with many of the government authorities, for this infrastructure development, because this is also the part of development when the industries are coming in. Then in some places we itself built a gas storage system in house in a data center premises. The small tanks, then the gas storage system links that piping with the DGs, so that we can run the DGs on a gas for a given time whenever the DG will start. Okay, definitely there is a cost factor and all the factors that depends on the capex and opex in discussion with the client, where client agree. But that is one of the solution which is available on the table, can be implemented. in India, very much used in the cities like I can say Maharashtra, where the pollution is a major concern. So DGs are shifting diesel. They are government is not allowing diesel, so automatically the generators are shifting to the gas-fired generators. So we suggested these solutions, and client are eager to implement. Yeah, definitely, along with the state government and local regulations. That's the things basically, because definitely there is one more thing which clients need to take care, I can say, and it's a very important thing when we are storing the high density diesel inside the premises. Even we are taking all approval, paso approvals, and all the taking care of the distance from the data center building and all, but ultimately it's a flammable thing which is available inside our data center. It's hazardous, creating hazardous atmosphere. Okay. Yeah, generally, yes, as per the law, regulation and international regulation, we all, along with consultant, all our reputed clients, taking care of the full safety measures. But still, we have seen, the many of the places, industries, like if you relate this minor thing with the oil and gas, the blast happens. Okay, so that is why definitely when the sustainable solutions came in, clients need to think about, how to implement it, and we are also working on this. So that's the say here.
That's great. Thank you so much, Mukesh. We've got just a few minutes left, so I'd like to move forward to some sort of final thoughts and key takeaways, kind of from all of our panelists. So, Amol, if I can maybe go to you first. Obviously, we've touched on a few things: the changing design principles, liquid cooling, renewable energy. I suppose, is there kind of anything from your side that you would like to leave our audience with? Any sort of final thoughts or key takeaways from developing sustainable high density data centers in India?
So, as we saw in the very first thing, that the high density market is growing like anything, and it is demanding a lot of power. But equally, we need to start thinking on sustainable approach, how we can make our data centers sustainable. Because I saw many times we keep on talking, but the first that needs to go behind making it sustainable are at very low. So Brahma has rightly pointed out, I saw their buildings, okay, that they've really taken that initiative. But likewise, each one of in the industry has to take that way, step ahead and support the environment. Apart from that, one, we should not forget of having a whole life carbon assessment of our building, because most of the times we design, we operate, but we forget to measure those black spots, I will say here in this case. So going forward, considering the high demand, we must target on measuring the black spots in our design and try to implement. And these are the minor things. If we try to capture them, we will definitely help one day to the our environment. This is what I can suggest. And we being an engineer, we must do all those things in helping us and helping our environment. So this is what I can say.
That's great. Thanks, Amol. And Mukesh, I'll go to you as well. I suppose, how do you see the high density market developing in India? And, obviously in this sort of such a rapidly growing region, what are the biggest sustainability challenges, and how should these be tackled?
Yeah, thanks. Definitely, yeah, market is growing. Yeah, everybody agrees with this. Okay, we are working with the clients, for the challenges. Yes, the challenges are really like, one of the main thing is, power. Okay, like Brahma also mentioned, while choosing the land. Okay, the you need to decide, what capacity we are going in, because right now we are going for the data center campuses, not for the one building. Okay, it's now the 5 buildings or 10 buildings inside one premises. So it's a huge capacity data center. And another thing I know down, the plantation in a data center, okay, which need to be maintained. Yeah, I recently noticed that, and I am working along with the government authorities to taking the EC approvals, okay, environmental committee approvals. Government is now coming up with a very rapidly on these things, like how to make a green data center. Okay, this is one of the aspect, the plantation in a data center. Okay, so that is also nowadays the mandate of creating this much of the plants and this much type of the plant according to the states and local requirement. And another thing is like the parking space is the EV parking. That is also the mandate nowadays. Okay, electric vehicle parking is available. Other that's the mandate from the state governments also nowadays. Then the opportunities, yes, definitely. If I talk about consultant, yes, it's a huge opportunity. Okay, we are working on a very good hyperscaler market in India, and all across the world, hyperscalers are taking this market very seriously in India nowadays. And I can say in down the line, coming 5 years, we it will be the biggest data center market in the world. Because I know the planning of the hyperscalers, I know the planning of the clients. Okay, they are really thinking very positive about this, and the positiveness only comes when your government is serious about this. Okay, so government is serious about building up and providing all kind of energy, power, and local services, water, everything on that particular data center nearby the area data center campuses or industrial areas. Yeah, so that's the thing.
Thanks very much, Mukesh. And Brahma, I'll let you have the last word if that's okay. Obviously, it's already been touched on how rapidly we're seeing this market growth in India. So, what foundations need to be built upon to ensure that India remains a prime location for further AI data center development?
It's a very relevant question for India and the present situation in the country. So, yeah, good thing is in India, the government is very focused. The central government and also many of state governments are very focused on data center business and the ecosystem around that. They believe in that. So part of that, the various state governments brought up a data center policy. Data center policy consists of various schemes and benefits for the data center investment. Same way, central government came up with the by enabling the digital AI workloads. MIT is the central ministry themselves came up with the GPU as a service, a GPU cloud for all the India business as such. There are very key initiative, very focused approach for the data centers expansion, the business expansion in India. So that is the first thing to look at. The very positive sign where the governments are very favoring the data centers to coming into their country. But if you look at Singapore, for example, they are slightly hesitant to allow data centers because of the country footprint itself is small and power resources, etc., is a challenge. Same way, Malaysia is almost all coming to that edge. So there, India is welcoming because there are key reasons. One is the government policy is very flexible in terms of incentivizing all the data center investments in India, and they are coming up with the flexibility in sourcing the energy, either the renewable energy or any kind of energy through open access and PPAs. And of course, those are required for the strengthening a couple of states. But as a country, they have a great vision. And adding 500 gigawatt of renewable energy to the country by 2030 is the game changing efforts from the central government, because the many of the hyperscale customers, neo cloud customers, looking at their basic obligation to the industry and society is the net zero or sustainability is their commitment. For that, this 500 gigawatt of solar energy coming into the country by 2030 is a great booster. They are all looking at, hey, solar energy is available. Another key aspect to look at is enabling, as I earlier mentioned, the customers having a lot of positive sentiment in India, because the India as a country and the players are quite adaptable and quite flexible. So they already looking at what customer needs. They started announcing multi megawatt, multi gigawatt, large scale campuses, which brings a lot of flexibility and scalability to the large scale customers, including neo cloud customers and players and all of them. Okay, that is another one. And the governments are establishing the very rigid power infrastructure. Okay, the power grid availability. Today, the most of the developed states in the country, the transco and generators, there is a point of discussion among them. How do we serve their data centers? How do we strengthen their network? It is a part of their recurrence of the meetings to serve the data centers. So that's where they are adding more and more EHV substations and power grid networks. That is another good positive sign. Of course, the data is already very much established in the country. Of course, they are keep adding the strengthening the network infrastructure across the country. Okay, and good part is we adapt fast, we deliver fast. So the constructability and related stuff, so very much matured in India because we have a lot of challenges. But if you see the last 3 to 4 years, the growth is more than the double. So still country could able to produce that much capacity in the country. So the global clients, the hyperscale customers or HPC customers or new client cloud customers are looking at India as the potential to deliver their capacities. So that is another good sign. So as the Mukesh highlighted in terms of the energy, the renewable energy. Now, customers are looking at sustainable and green energy, and that's where the country is working towards. The customers always wanted to have 100% renewable energy. 100% renewable energy. Today in the country, they have certain regulations where the regulations are not allowing 100% renewable energy to draw from the solar parks. The state utilities are restricting data center operators to go up to 60%, 70% of the total energy from the solar or renewable energy. Rest all should go. It's a mandate to draw from the local utility companies because of they have their own cross subsidy, free power kind of obligations. So here, to sustain, to come out of that situation and provide, around the clock green energy, the government also coming up with many other schemes. The part of the solar and green energy, solar power, best battery storage is another one. Another one is a pumped storage, hydropower plants, which can produce 24 hours on energy. So the combination of all the solar, either BESS or the pumped storage or the wind energy, with that combination, people are exploring to go up to 100% renewable energy if the government permits. So having all these long-term plans and to support the customer, start from his 1 megawatt to 10, 15 gigawatt of kind of capacity to support, the country is getting ready. That is a positive, and those are the foundations. The government and all data center players are really working towards that, which is good for all the global players. That's where India is going to be a prime location. It is going to continue to grow.
Right.
Absolutely. And a great note to end on. Unfortunately, I will have to wrap it up there because we are out of time. But thank you so much to Brahma, Amol, and Mukesh for joining me. It's been a pleasure speaking with you. And I hope you've enjoyed the conversation as much as I have. Thank you, of course, to CtrlS Datacenters for partnering with us on this episode. Do check out the resources for some further information. Reach out to the speakers if you have any questions. Reach out to the team at CtrlS. I'm sure they'd be very happy to hear from you. This episode will be available on demand shortly, and do tune in to the next episode coming up in just a few minutes at the top of the hour. Thank you again to our audience for watching, and thank you again to Brahma, Mukesh, and Amol for joining me.